Hi, in this project, as the name suggests, we will be predicting the ratings of apps, taking the data from Google Play Store. Then, we will be building a web application model to predict the ratings and deploy that web application model to Heroku. Now, what exactly are we going to do in this project? So, we have a dataset that contains information for apps that are present in Google. It states out some of the characteristics of these apps. This information is actually scrapped from the Google Play Store, and we will be using this dataset to predict the rating of the apps. Now understand this, the dataset was not actually prepared for predicting, but for analysis of the apps as to how popular they were, what were the reason they were so popular. So we have to do a lot of pre-processing before we can fit the model onto this dataset. Now the details of the project. The project is actually divided into three parts. The first part is building a machine learning model to predict the rating of the apps. The second part is where we will build a Django web app, that is a framework for building web applications, and mount the prediction model onto this app. Lastly, we will deploy the Django project on Heroku using GitHub. Now the first part, that is building the machine learning model. So we start off with building machine learning model, and we use a random forest regressor model and train that model using the Google Play Store data points. Now one thing to note here is that this dataset will require more feature building, just like I said before, and extraction than exploratory analysis, because this dataset was actually created for inference building and not for prediction purposes. And you will understand why I'm saying this once you look at the dataset in the first part where we will be building the machine learning model. Now in the second part, that is Django web app, we will be building the web application using the Django framework, and then we will mount the model we have built in the previous part on this Django project. Now the last part is deploying the web application on Heroku using the connections to GitHub. So now we will move forward and go to the first part, that is building the prediction model. So this is the first part of the project where we will be building a machine learning model for prediction of ratings for the apps. Now, as you can see, the first code block here is to mount the drive folder onto this collab notebook. Meaning, now we can access the files stored in our drive folders from this collab notebook. And as you can see, I have mounted the drive folder from my content directory onto this collab notebook. Now next you can see is the importing of libraries that we are going to use for maybe data manipulation or data handling. So here you can see the first library is NumPy. Now it is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on array can be performed easily and very efficiently. So the next you can see is pandas. Now it is a library for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. So both of these are actually for data manipulation or data handling. But the next two libraries, as you can see, are the Seaborn library and Matplotlib library. So while Seaborn library is for making statistical graphics in Python, similar to Matplotlib, but it actually helps in exploration of your data in a much more visualizing manner as compared to Matplotlib. Now both are for visualization only, but in case of Seaborn, the way you can visualize your data is much more extensive, and the palettes it requires or provides you actually is much more intensive, I would say, as compared to matplotlib. So in the next code block, you can see that I've used the function read underscore CSV to call out the CSV file and store it in the variable apps. Now, apps is actually a data frame. Yeah, apps is actually a data frame, right? And using the function head, giving the parameter 5, it is now showing me the first 5 data points from my data set. And now you can see that the first 5 points are now shown here with all the columns present. And as we discussed, the rating is what we are going to predict in this project. Now you can see there's a column that has the name of the app, category, rating, reviews, size. I've assumed that the M is actually for MB, okay, and then installs, type if it is a free app or a paid one. If it is a free, then 0 is the price, or else for the paid it would be a, yeah, it would be specified. Then we have content rating, genre, again somewhat similar to categories. Then last updated, current version, and Android versions. Even if you are able to see, or if you're not able to see, let me just specify that this dataset requires a lot of pre-processing before you can even start with exploratory analysis. And that is because the first thing I would like you to see is the size. Now it is written 19M, and this is a string which has numerical values. So you have to extract the numerical values from here. Again, you are able to see that in the Android version, there's the Android version, and then it is written and up. So again, a numerical value that is actually stored in string format. So even if you look at installs, it would be later, it would be later revealed that this is not actually in numbers or in numerical form. It is again in string form only. So you have to extract all of these data before you can do anything with it. So the first thing I'm looking at is the shape or cardinality of the data set, which is 10,841 rows, meaning 10,841 data points with 13 columns. And if I type in describe function, so basically describe function works upon on an series or a data frame, and it gives you some statistical outputs that you can see here, the quartiles, the maximum, the minimum value of that column. Now describe function only works upon numerical data types only, and again you can see that I have given the describe function the data frame, but only ratings is the output for this function, meaning that from all of this data, only the ratings column is having the numerical value. Next, yeah, so next you can see is that I am trying to convert this string format of the date into the date format, right? As you can see, the type of P is string, meaning I'm inputting the S, that is the string, into the parser, and the parser is understanding that yeah, this is a date, but this is still in string format, so it is giving you the type of string. Later on, what I'm trying to do is convert this string into date format. So what will happen now is that first, this April 25th 2020 will be converted to 25/04/2020. Okay, so again this is in string format only, we haven't converted into date till now, but this will be helpful later on where we are going to, yeah, where we are going to convert or extract more information out of this. Okay, for now we are just using the parser, and we have created a function so that we can just run the map function, and this mapper function inside would be updating each and every row for this column. Meaning, as you can see here, January 7, 2018 will be converted to 07/01/2018. Then the next column, the next row in this column, which is January 15th, 2018, will be converted to 15/01/2018. So likewise for each and every row for this column will be updated into the date format. Well, not exactly date, yeah, in the date format, but not in the date type. So this is something to note here, right? So in this way, we have updated one of the columns, and later on you will see why I have updated in such a way, because this helps me in extracting the data from the date format. Now the next is the is null function and the sum function. So what I'm trying to see is the null values that are present in each of the columns, okay? And the sum function is helping me to, so is null function basically tells you if there is a null value present or not inside your data frame. And with the sum function that is appended here, you can see that it has given me the number of null values present in each of the columns in this data frame or data set. So now you can see that the rating has 1400, at least 1400 null values, and the rest have only 1, 2, maybe 10, and so on. So with this, you can see if there's null value present in your data frame or not for each and every column present inside the data set. So next thing what I'm doing is dropping the null values, and with the parameter any. That means that if there's any null value present in that row, you have to drop that. And with that, you can see that the number of columns have diminished a little using again the shape function. So this is the reason why I was converting that date format. Though it was still in string type, now it has converted into date type with the help of to underscore date time function. You just have to input the column in which you have to make the conversion, and since the format was already in the form of, yeah, since the format was already in the form of year, day, month, right? If you want to convert the format, or if you want to change the format in some other way, what you can do is type in format, since it is also a parameter for this function right here, and you can just type in maybe day, month, year, or in any way that you want. So now this last updated is actually changed from a string type to a date type format, right? Next, as you can see, is that I am now trying to extract the information from the size column, meaning I'm trying to remove the M, right? So what I'm doing is, again, I've created an function that can be inputted into the map function here. So what happens is that if you're using the map function on a series and you have given another function as parameter, then what happens is that for that column, each and every row will be updated using that, or I would say using this function here. So this function works upon each and every row for this column, right? And now as you can see, first what I've done is I've taken all the values present inside this this column into a list. So once I've created the list, what I'm doing is I'm inputting, or I'm taking or showing you what this list is holding. As you can see, it is yeah, that is not what I wanted to do. But as you could have seen, the list was storing the strings, right? But what happens is that once you use this map function, it is going to extract the numbers from that string and then convert into the float type. So what happens here is that I'm taking the string from the 0th index to its length minus 1th index, right? Because the last index is storing the m. So once I remove that, I append that, so I only have the number with me in string format, which is then typecasted into float. Now, if this is not happening, or if there is an exception here, then what I'm doing is counting the number of time it has occurred, meaning that maybe the column didn't only have numerical values stored, but also strings that didn't have any numbers with them. Maybe the column in this column, the size column, maybe there was a column which had varies with the app or varies with the system. So there's no 19, 20 or 55 or any number written. That so here we cannot convert that into float. Thus it would give you an exception. Now once it goes into the except block, here I'm just counting the number of times this happens. Now you can see that it has happened 1900 times, right? Meaning there were no numbers present in this size column that were 1900 times. So again, I'm going to remove them because they will be creating problems later on, right? So again, I'm removing them here. Next, as you can see, is I'm trying to extract values from the Android version. And as you can see, I'm just trying to get the first number, that is Android 4 or Android 5, maybe 6, 7, 8, 9, right? So as you can see, if I split using the split function, having the parameter a full stop, because a full stop is present here, then S is actually a list that is storing the strings 4, 0 and 3, right? So you will be seeing what I'm going to do with this, right? This is just an example block to make you understand later on what I'm going to do with this to extract the information from Android version. Now I will be stopping here, and the next video we will be learning more about the categorical data that is present. So yeah, we are now going to start with the categorical data type that is present in this data set. And the first you can see is the type column that has two values which are free and paid. Now there are 577 paid apps and 7149 non-paid or free apps, right? And the next you can see is the content rating. Now content rating has six type of categories where only one is unrated and two are adult only. So see, using the value count function, we can see how many type of unique values are present inside this column and then the number of type they have occurred, right? So for this content rating, that is everyone, it has occurred 6166 times, right, inside the data set. So with this function, we can actually see if there is a categorical data present. If there is, then each category has occurred how many times, right? As you can see, the genres has 112 categories. Now, these are a lot of categories to extract information from, because in the way that we extract, we try to create new columns or give numerical values to these string ones, right? So having 112 numerical values will confuse the model, or creating 112 new columns will expand this data set, which is not what we require. Next, you can see is the category. Now again, using the value counts function, we see that there are 33 categories and family has the largest number of frequency, then game, tools, and then it dumbed down to 324, 280 and so on, going on to 95 and so. So now it has 33 categories. Again, this is a lot number of categories, but still we can work with it, right? So you can see that I've imported a label encoder. So what label encoder does is that it helps you in converting your categorical data, that is string data, into numerical data, right? So that that data can be fit into the model. So I've called the class and used its function fit to convert or start converting, not start converting, to understand which category is present inside this column and what to do with that. Then we use the transform function. Here transformation happens, that is, here the numerical data is inputted or replaced by the string data. So you can see that the classes it understood from this column was art and design, auto and vehicles, and so on. Next, you can see that I'm again using the fit and transform function for the content rating column. And then what happens is that you can see the classes were these, meaning the categories were these, and then they are transformed into 0, 1, 2, 3, 4, and 5. So 0 corresponds to adult only, 1 corresponds to everyone, 2 corresponds to everyone 10 plus, and so on, right? Next, you can see that I am again using the map function. But here what is happening is that this function has been defined, which takes in each and every value in the type column and sees if the value present in that row is paid. If it is paid, then return 1, meaning this 1 replaces the paid. And if it is free, then it returns 0. Right? Now, I have dropped some of the columns which were not exactly helpful in providing any type of information, or maybe they did contain information but were not exactly in a way that we could use or the model could understand that. So you can see that the again categories has been converted to numerical data. The size again is converted to numerical data. Type is converted to numerical data. Content rating is converted to numerical data, right? So next we work upon installs. So in this column again we have to remove this plus sign and convert the rest of the string into a number. So what we have done is that, yeah, we have created another function, and this function helps in the way, see, what I've done here is that first I converted the app data into list, right? This list contains all these values. Then I'm calling this function, and for each value that is present inside this list, right? In this list, I'm searching if the string starts with varies. Now why I'm doing this is because in this column there's not only numbers, there's also a string that says varies with system, varies with the app, varies with the Android version. So if there's a varies, I would say if there's a varies of any kind inside the string, then you have to remove that. Okay. Sorry, if there's a vary of any kind, then it goes to the else block, right? If there's not any varies inside the string, then you just take on the string and remove the last part, that is the plus part, and then convert it into float. If there's a varies and it goes into the else block, then what you have to do is append the average value. This was the average value I was able to take, right? So as you now can see, first, when I converted the series into the list, it had string values. Later on, when I'm going to use the head function to display the data, you would be able to see that the installs also have been converted to numerical data. Okay, so in the, yeah, here what I'm again doing is converting the reviews, since again it was in string format, to float by typecasting. Now, what I did in the first part where we were converting the string into date, so this is where we are now extracting the information from date. Using the date time library, we can extract the year, month, day, even day, weekday, name of the week, weekday, or maybe some other type of information that is related to dates. So with that, we created three new columns, right? And in each, it is stored year, month, and day. Next, I'm trying to extract data from Android version. Again, as you can see here, what I've done is if the column has no string which starts from varies, then what you have to do is take the first three characters of the string and then convert it into float. Okay. And if the string starts with varies, then it comes into the else block and just append 4.4. Now, again, as you can see, when I converted the series into list, it has, I would say, it's storing the string values, right? The same I did for prices. I just replaced the dollar sign since dollar was present before the numerical value in the paid version of the prices, right? The rest were to written zero. So now, yeah, now here you can see installs were converted to numerical type. From date, we are able to extract the year, month, and day. Day is actually date from 1 to 30 or 1 to 31 or 1 to 27 or 28, right, for February. Then months are like January to December, December being 12. Now we can feed this data into the model, right? But before that, we are just building a correlational graph to understand how, and I would say how each and every column is influencing the other column, right? As you can see, we are trying to predict the rating, and here you can see some numbers that are for rating. With rating, it is 1. Rating with category is a very small value. So in the next part, I would be actually telling you more about correlational graph and what to infer from correlational. Yeah, so let's first understand what a correlational graph is and what you can infer from it. Now, basically, correlation is the dependency where you can see that how much influential one thing is to the other. Let's say, for example, that there are two columns, category and rating. Now, this value represents how much influence category will do to rating if there is a change in category. Meaning, let's say that I input another category, right? And now there are 34 categories. So how much change will be produced in rating? How much influential category is to rating? That is defined by this number present here. And correlation is always between 1 and minus 1. 1 being that if there's a change in one thing, then an equal change is going to happen in the other thing. For example, if the value for this block was 1, that would have meant that category, if there's a change in category, then an equal change in rating would be produced. Similarly, a value of minus 1 shows that if there is a change in one thing, then an equally inverse change is going to be happening in the other thing, right? So with that in reference, the values are from 1 to minus 1, and you can see a heat map being built for each and every column pit against the other columns. Now you can see there are some values that are higher than the others, as the year to the Android version value is 0.53, meaning if there's a change in year, there's going to be a change in Android version. Another way to look at is that year and Android version are very much related to each other, right? Again, installs and the reviews are also much related, and that is because if there's going to be a very good review or very high review, again, it would have meant that a lot of people have installed this, or a lot of people are going to install it, right? Because the reviews have been so good. So in this way, you can infer how each and every column is being related to the other, and in turn be able to understand which column is able to produce much changes in the rating or in your prediction column. So with that, we are finally on to the point where we are going to build the machine learning model. Now, before doing that, what I have imported is a PCA. So PCA library is basically a library that has functions which are able to make concise or summarize the information that is present in your data set, so that you will be able to minimize your data set or reduce the dimensionality of your data set. So what happens is that if you give the parameter n components is equal to a number, then the transformation happens on your data set, and the finalized data set would be having only that number of columns. So we started off with 13 columns, remember? If we remove the prediction column, right, the ratings column, we will have 12 columns. And then we created some more columns out of dates, right? So now if I use PCA and if I use the function fit and transform, what happens is that now the data set having maybe 12 or 13 columns will be squeezed down to just 5 columns, and all the information that the original data set had would most probably will be retained in those 5 columns in the output data set only. Now again, if you're trying to reduce the dimensions from 100 to 3, of course there's going to be a loss in the information. So there's always going to be a trade-off between the reduction in dimension and the information lost. So I'm only taking the first 1000 columns, or sorry, rows or data points, because if I train the random forest regression model on the whole of the data set, it gives me a very large model to save, and Heroku doesn't provide you with much server space, so it creates a problem there. So with that, what I've done is just use the transformed dataset as my X train and X test, and the Y dataset which has the ratings, right, having the test size as 0.2, meaning that now train and X train and Y train will have 80% of the data, that are 8,800 rows, and then next 200 rows would be for X train and Y, sorry, X test and Y test. Now here you can see that I've called the random forest regressor with the estimators as 200, and the n job is equal to -1. Now this means that it is asking the system to use all the processors to train this model, and the random state as is equal to 42, meaning that you have to shuffle the data while training or before training. So I fit the model, and the accuracy is 89.3, which is okay. But as you can see, the accuracy for test data is only 43.45, which is very less. Now, as I told you before, this dataset was not prepared for prediction, but was prepared for analysis. But again, as a challenge, I would ask you to maybe try to get more than this value here, right? Maybe extract some information that I did not, maybe do something different to get more accuracy for your test basis, right? So the next thing that I did was just to save the random forest regressor model and the PCA model, because again, if I'm going to predict, first I have to squish down the data using the PCA model, and then I can input that squished data into the random forest model to predict, right? So I've saved them using the pickle file or the pickle library and stored them as pickle files, right? Yeah. So with this, we have finished the first part, which was building the machine learning model. And next, what we are going to do is create a Django web application to mount this model. So this is the second part of the course or project where we're going to build a web application using Django framework. But before we move forward to the code part and understand how it works, let's first understand what Django is. So Django is a Python-based free and open source web framework that follows the model template views architectural system. It is a web framework that has a set of components that helps you to develop websites faster and easier. Now, as you see that in Django, when you start a project, you're already presented with a pre-built set of environment and pre-built site itself, where what you can do is maybe update this project or append new things into this project. Similarly, many of these security vulnerabilities are handled by Django itself. You don't have to change, maybe you can change if you want to, but in itself, Django provides you with a lot of features that are pre-built and already handling how the site is going to work. So if you want to change how the site is going to work according to you, you can go and change the settings in the settings.py file, or you may update or append new things into your Django project itself. Right. And this is why Django is pretty easy to use to build new websites and also pretty easy to handle also. Now, let's first understand what we have to do to run this code. So you can just start with the project directory, right? Just build a project directory where you're going to store this code, then build an environment for that project. Okay. So as you can see here, I've already built an environment named VNV underscore apps, right? Now, what this environment will help me is that it is going to install and store all of the packages that are required by this project, right, to work with. So what you have to do is once you build the environment for the project, now if you're on PyCharm like myself, what you can do is go to files, right, click on settings, and when settings opens up, yeah, so click on right here project, and this would be the name of the project you have specified. Then click on project interpreter, and as you can see a project interpreter is specified here. If there's nothing present here, what you can do is click on the settings button and click on add. Once you click on that, a new pop-up is open and it asks you to either create a new environment or use an existing one. So click on new environment, then set the Python version. Since I both have 3.7 and 3.6, I've set the 3.7, right? And name the environment and click on OK. Once you click on OK, it starts to create a virtual environment, and this might take a little more time, right? So once it starts creating environment and is done creating the environment, then what you have to do is install all the packages that are required by this code, right? So here you can see that there's a command written pip install r requirement.txt. So once you type this in your command line, what will happen is that all the requirements for the packages is going to be one by one installed in your environment, and then it is going to be set up there. So once that has been done, you can see that there's a my site directory, there's a poll directory, right? So in my site directory, you can situate the situation settings.py, and polls. This is an app, right? There's a difference between this my site and polls. So polls is an app and my site is in project. Now project handles how Django application is going to work, and polls handles how the features on the application is going to work, right? So you can even see that how to create a new project, how to create a new app. Next, what you have to do is in the command line, go inside the my site directory. As you can see, this is my project directory, this is my site directory. Once you go in here, what you have to do is type in this python manage.py migrate. Now this command is actually used to establish all the pre-existing tables that are going to be required by this Django application, right? And once you do that, you will see that a lot of tables are being created or altered, right? And in these tables, what there is that some data is going to be stored, which again later on might be used by Django. Right. So for that you have to run that command. And the last command you can see here is the python manage.py run server. Now this command actually runs a local server onto your PC, right, where you can see how the web application is doing. Is it working properly, or is it having some glitches, or maybe not working in the way you want, right? So this last command is what we run once we have completed, or I would say once we have created the project, created the app, made some new features, and now we want to test those features, right? So this is run then. Now the first thing to understand here is the settings.py. So in settings.py, if you go up, yeah, here you can see that there's a debug, then there's the allowed host. Now allowed host is basically here so that we can specify on which servers are we capable of running this code, because they have to be specified here, or else it would understand that yeah, no server is actually in requirement of these code and it won't run. Next is, as even you can see here, installed apps, and here you can see polls. So this polls was created by us, but these these apps are actually pre-created by Django itself when we start a new project, right? And you can see that an admin, authentication, sessions, they have different apps which are handling the sessions, handling the authentication, and so on. So you don't have to create the authentication part or the sessions part from the scratch. What you can do is just go inside the app and maybe append or change something according to your requirements. You don't have to write the code from scratch. Next, even you can see the middlewares are also pre-existingly created, and here you can see the security middleware is there, session middleware is there, which might be using these session apps, right? Next you can see, yeah, next you can see the database. So again, this is a web application, of course it will be requiring a database, right? So here you can see that SQLite 3 is already being installed, or engine for SQLite 3 is already been installed with Django, right? And once you do that, right, once you do that, an SQLite 3 engine is going to work with this Django project. Now what you can do is maybe change this value to some other, or change this value to a pre-existing MySQL engine that you might be using, or maybe a Postgres engine that you might be using. So you can change the engine here, and then this application is going to interact with that engine only. And the last, you can see that we have defined some static URL and root. Now what is this? So basically there are some static files in your code which are actually handling the interface on the HTML, right? Even you can see that the static files are CSS, JavaScript, or images. So once you do that, the static URL is telling you to from where would you fetch the static files, and the static root is telling you to where the static files are to be stored in, right? So this static files will be actually a directory created when the code is set up on the server, and from this path the server will understand that yeah, from going to static we will be able to find the static files. Okay, so once this has been cleared, let's move to the views. So what are views? Now, first of all, understand that views is particular to a app. For one app, there's going to be a one pre-existing view right here. So anything that is related to data manipulation, data storing, data handling is done here, right? So what happens is that we have a template, right? A template is actually an HTML file from where we are getting our data. Now, as you can see, this is an HTML file where we have a form, right? A form is taking some values, right? And here you can see different kinds of values are being then submitted here. And once you submit all of that data, then comes here, which is, I would say, the actual backend. And now what I'm doing is actually just storing the data inside different variables. So this function is called, right? So once this is called, it understands that there was a form which was filled, and that form is now trying to send that data over to here. And once it sends the data, I have to store the values. So I store the values in different variables. Now I'm just creating a data frame, right? I create a data frame. Then I first load the pickle file for the PCA so that I am able to transform the data set. Again, as you can see, it has more than 5 columns, right? So we have to squish it down to 5 columns. For that, we need PCA. So once we have transformed, then what we do is we send the transformed data into the loaded model, right? We send the transformed data into the loaded model for prediction. So you can see that I have loaded the model. So this is my loaded model here, and then I'm doing the prediction with the transformed data and printing the result. So with this, what we were able to do, we were able to send the data from the front end to the back end, right? And then from the back end, we were able to process it to find the result. And the last thing that we are going to do is send that result back to the front end. And how that is done is you can see that there's the return render function, and in the render function we have this, which is called context. So as response, I'm sending the result, right? And here you can see that HTML, an HTML file is also present here, which is named index. So what happens here is that this function is called. Once this function is called, it stores the data, manipulates the data, and again returns the result. And it understands, I mean this function understands that it has to render the HTML index and has to return the output or the result to the index page or the index HTML page, right? Now you must be thinking, we haven't called this function here. You can see there's no call for this function. So what happens is that the calls are not made from here. The calls are actually mapped in the URLs. Okay, not this URLs. Yeah. So you can see that there's a function path. Here you can see the index function, the name of the index function, right? So what happens is that we have to define a path, and once we go on that path on the server, this function will be automatically called. So once this function is called, you just go on to that path, and once that path is loaded on the web page, this function is instantaneously called. And once you call that, what happens is that first this function renders the HTML page, then from that page you take on the data which is then stored here. We have manipulated and got a result. Once the result is present, we send that back using the context, right? So this is how it works. Now the last thing is that before we move forward to deploying this project on Heroku, what we have to do is understand about some files that are to be created and send with this code so that Heroku servers are able to understand how to set this code up. So that would be specified in the next part, which is the last part in this project, where we will be deploying our web application on Heroku. As I said before, so when we start off with Heroku, we have to first understand that there are some files which are like commands for Heroku to understand and use. So let's first understand those files, which are runtime.txt and procfile. So runtime.txt is basically just telling Heroku which language or base is to be used by the server. Then as you can see, the next file is the procfile. So procfile is like a mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part, like run server or migrate, these commands are executed in Heroku server using the procfile. And these are very much important too if we want to set up the code. Now, before we directly move forward to Heroku or Heroku platform, let's first understand one thing. That is, once you have created the procfile and runtime, what you have to do is upload the code onto the GitHub and then repository, right? So as you could see, I've created a repository apps ratings, right? And in the master branch, the code is present. You can see the procfile, the requirement.txt and the runtime.txt. Now again, requirement.txt is just a file which stores each and every package that has been downloaded or is being in use with this project and the version for that, right? So the project, I would say, is to be uploaded in the same exact format where my site and polls and flow and each of these files are present, right? Even you can see here that in environments it is active, meaning that some server has already created an environment where this code is set and used. So once you go into your Heroku, what you can do is, if you haven't made an account, just make an account. It's very simple. And once you log in with your credentials, you will see a personal dashboard, right? Where all the apps that you have created are going to be present. Now for free versions, only 5 apps are to be made, right? And here in this button, you can click and go for to create a new app. Once you click on this, it would ask you to type in the app name. Then it would ask you to choose the region. There's only 2 regions, right? And then click on create app. I've already created an app for this and you can see apps rating, right? So this was the app that I created. So whatever app did you create, you can just click on that and it would show you some overview, deploy, metrics, activity, and so on, right? So the first thing that you have to do is go to settings. In settings, scroll down to build packs. Here click on add build pack, click on Python, then click on save changes. Then you would be able to see that Python is the language that is going to be used on the server. So you go to deploy. Then in deploy, you can see in the deployment method there are 3 methods, right? And you can see I have chosen the GitHub connected method. So once I click on this, I would be asked to set up a repository that is to be connected with this app. So it would ask you to set up or connect your GitHub account with this app. And once you click, there's going to be a connect button here. Click on that. Then it would ask you to type in your credentials for the GitHub account. Once you do that, then it would ask you to connect a specific repository from your GitHub account. Again, there's going to be a search bar and search option. Once you do that, it would show you the repository that you want to connect, and there's going to be a smaller connect button here. Then just click on connect. Then it would show you something like this: connected to the repository by the user, right? Next is you have to come to manual deploys. In manual deploys, choose the branch to deploy. Now, as I told you, the code was set in master branch in my repository. So I choose master and then I click on deploy branch. So once I click on deploy branch, what happens is that now the server is started, and then the code is going to be set up on the server. So you can see that using build pack, it has understood that Python has to be used. And then from the runtime.txt, it has understood which version of Python has to be used. Next, what happens is that from the requirements.txt file, it has understood which all packages are to be installed and used, right? Then with the help of procfile, it is now running the collect static commands. Again, this command is specific to Django, not Python. And this command actually helps in allocating all the static files from all the apps to just one place, that is the static files folder, which we defined in the settings.py. Lastly, it would compress the files and then release a version of this web app. And once it has completed this humongous process, which might look small from the user point of view, but actually a lot of things are happening in the server side, it would give you a view button here, and it tell you that it has been deployed. See, deployed to Heroku, there's a tick here and a view button here. So once you click on this, it might take a little time. Okay, then you just type in the name. Okay, Spotify, select the categories, family. I know this is not a family, but anyways, okay, paid or not, it is paid. Price 120 for a month. Everyone, I would say, year it was released, maybe 2014. Yeah. Oh, now if I click on submit, now you can see that the rating is 4.1095. Yeah, it is like to be so much exact, but you can say that the rating is 4.1, right? So with this, we have completed the project, which was building a model for predictions of ratings and then building a web application to mount this model while we deploy this lastly on Heroku.